Good evening, everyone. How are you doing today? Good. Okay, let me start the presentation. Today I'm going to talk about the re-architecting the metadata. Okay, let it go first. So everybody know Uber, right? I don't need to introduce the company, but I want to share something new. Anybody in this room took Waymo? Shaking your hand. Anybody took the self-driving car from Uber? No, right? Okay, here's the news. In next year, in San Francisco, Uber will release the self-driving car. Okay, at that time, you can use the Uber app to call the self-driving car. So that meaning Uber extends the business to the AV industry. The second new thing, we know Scare AI, right, change. The CEO moved to the Meta, better position for him, congratulations. But after the org change, Scare AI lose a lot of customer account and order. And which company got some order from the Scare AI? Anybody know? Yeah, Uber is one of them. And Uber is doing the AI solution. Actually, you can imagine Scare AI work. And Uber is turning the business to the labeling industry. So, okay, why I need to talk about that? Because Uber is like a full life cycle, full sprint of the data, including non-structured data, semi-structured data, and structured data. We are encountering a lot of challenge. Number one, so we are handling multimodal data at this moment, right? How to do the data fusion. And if you talk about AV is much bigger than the traditional cloud lake. For next year, our AV data will be beyond the Uber Cloud Lake. Uber Cloud Lake is something like 100 terabyte data in the cloud. And Uber is proceeding the largest cloud migration today. And we are moving data from on-premise to cloud. We have a lot of cost efficiency. Okay, by the way, people think moving to cloud can do more cost saving. The answer, like Uber scale, maybe no. Right? And we need to do a lot of work to control the cost. The family, right, I think is very popular right now, the agentic AI, but how to say the contact to the AI agent to let them more effective is challenging. Okay, we are seeking an intelligent layer, can understand, decide, and act to accelerate convergence, efficiency, and intelligence. And what is it? Is it the metadata catalog? Yeah, I think that is today's topic. But before we go to the re-architecture, let me take a look about the old step for Uber. We have our internal metadata catalog we call UMeta and a data book. It is a very decent traditional metadata catalog solution. It's a governance center. Everybody put their policy over there. And they cover all structured data elements, all structured data, from the Kafka and to the report analytics. And they do life cycle data care, like insurance. You can get all the detail from the data from life cycle. And also the better job to do the data democracy and the marketplace. People can come here to check the data set. Pretty well done. And even we had a communication with the data break, and they are thinking the Uber, the data book is better than Unity catalog in some way, right? But we have some limitation. Number one is read-only view, because they put the data and generate the view. They couldn't change. Number two, it's not a control plan. That meaning it's not in the critical parts. Number three, no multimodality. They only understand structured data, no intelligence, all of them rule-based, and no self-evolving. That meaning the metadata you only can give to them, but they couldn't generate the metadata by itself. The last one, right? Static, no action, enforcement. It's not what we want. So Uber decided to re-architect. I'm using re-architecting, so because we are still in progress. And the vision was the metadata is no longer a registry. And it is the intelligence layer of the AI era. You can see the picture generated from the notebook LM, very familiar, right? The old way is our data book, and the new way. So the idea we want to re-architecture the metadata, we want to reshape the metadata catalog to execution brand. Okay, think about that. The metadata should understand your data, content understanding, they understand your data. Number two, the Met catalog can have AI reasoning and automation capability. The last one, the metadata catalog should be control plan, and they can take action. Okay, so this is a very high level. I'm going to do some deep dive, and we call the value driver. So why Uber decided to change and how we change. Okay, probably we have five. The first one we call value driver number one. I think that Pinterest will have the talk later, the similar challenge. Because we think about the catalog should support more AI workload. It's very typical in the industry like AI infrastructure, right? The big challenge is, okay, I need to run AI ML training and serving, but where is my resource? Computer resource, GPU, basically. And where's my data, right? And Uber is sitting on very complicated environment. We have multiple cloud providers and also our on-premise. We have different type of GPU cards, right? And so NVIDIA for sure, and AMD, and also we are using GCP, and so the TPU is very amazing right now, right? So, and we try to do the global scheduling, right? When we start a job pipeline, we are able to close the computer and the data. Okay, so the requirement for the catalog, the strategy maker for AI ML pipeline and job placement. So what's that meaning? So we develop we call internal, we call UFlash is our catalog name. So it has global routing API. So this global routing API is the cloud provider, the CPU provider availability. So we are able to know in real time where are the GPU cards, right? In which zone we are able to search them. We got their footprint in the real time. And then we know where the training data. And then the routing API, they're going to make a computation. Think about the ROI. So for example, if the data on OCI, Oracle, but the computer on the GCP, and then they will make a hard call, right? How we move the data, or we move compute, or we shift the compute. So the global routing API will tell the AI ML job where you should go. But if they decided to move data with the compute, for example, oh, my data on the on-premise OCI, but my compute on the GCP, it's cheaper, it's faster. And then the catalog will send the signal to the data sync service. Data sync service will move data dynamically in the real time. Because the reason why we need to do that, because the training data set, to be honest, sometimes you train the job, fine-tune the job, the training data set is not so big. Maybe, right? Maximum 100 terabyte data. But then you can reload, reshuffle the data to the computer location, right? And make sure when they do the AI computing, they are co-located together. So the behavior is dynamically place or adjust the computer and the data with the job scheduling. Okay, solution. So as I said, the UFlash, we just build abstraction layer. It doesn't matter you are serving or training. To us, it's just a producer for the demand, right? You want data, you want a compute. And then they come to the catalog. Catalog will decide it. We'll give you a suggestion. Where you put the computer, where you put the data, and depend on your job. And we launched the project to help our AI infrastructure make a smart move, right? So they don't worry too much, okay. Otherwise, you have to do remote load, right? And read some data for your training. We know if you started the very big distributed training, you need to do checkpoint, you need to access the data high frequent. And we also launched a caching solution, the catalog able to talk to distributed cache. Okay, cache the data and include the locality. Okay, so this is the first value driver. It's very popular from the industry who are running your own infrastructure, but you need the data co-located with your compute. The second one, yes, it's not so fancy, it's not AI, but it's like kind of like a dirty work, but we have to do, right? The cloud migration. The cloud migration summarized to be global optimization. Look at the picture. You want to move a lot of data from on-premise to cloud, right? Your pipeline, your job, mostly like a batch compute, right? And how they are doing, right? If you want to duplicate the data, you need to transport the data between the cloud provider and your on-premise, very expensive, and very, the latency is high, the consistency is a problem. If you don't do that, you turn on remote read. So I'm running the GCP, but I call my on-premise data, right? And there's a reliability issue. right? It's a low performance and also choke our network. So then we asked the catalog to say how to do the data workload placement optimization, global optimization. The goal is maximum locality, minimize remote access. Okay, so what we did, we just design and implement a smart data migration catalog service. So we call Mario. So we published a paper on SOSP 2025. To look like it's just a smart algorithm, so able to identify the dependency with the work, job, and the data. And anytime you want to do the cloud migration, you just ask the service. The service will give you the subset of the data set associated with their pipeline. They say, hey, you move this subset data and the pipeline, you're able to reduce a lot of remote rate, right? Improve your efficiency. And I think that's interesting, and we think cloud migration is one-time work, right? You from on-premise to on-cloud and done. No, actually in the real production, you probably need to pull the data and the workload back to on-premise. Why? Because as I said, global optimization. Sometimes you put the data back to on-premise, you can move other big portion to the cloud, right? It's back and forth. But it was decided by this catalog service. Okay, value drive number 3. I'm not sure the audience, how many of you are running infrastructure and data platform. It's a big challenge. I'm an owner, I know how important we are looking for, right? So how to turn the data infrastructure signal into clear strategic insight and automate operation. As I mentioned, you go to cloud, you have a lot of convenience and benefit, but the cost is very, very, very painful, right? So you need to collect so many metrics, and you're operating your infrastructure. And based on those metrics, you probably need to do attrition analysis, right? You want to find anomaly, right? For example, some owner, they use this bucket too much, the job is running anomaly. You need to identify them. And or you put a lot of data, but the different compression algorithm can give you different storage efficiency, right? And sometimes you maybe get the big ask. Can you do 2026 forecasting? How many CPU core you need? How many storage you need, right? And people have to do a lot of manual computation. So Uber developed the Data IQ. Data IQ is we call info op or data op. It's a more agentic solution. You can ask a question, or it itself is like a offline data agent. They can keep doing, do a kind of like cleanup, right? To redo the layout and relaunch the algorithm for the compression. There's some example like this. So Data IQ, they do a couple of things. So they can tune your caching algorithm. They can optimize your table layout, and they can find the duplicated data and try to do the, we call DLM, data lifecycle management. And for different data, you have cold and hot access. They can adopt the different compression algorithm and level to your data set. In the same time, Data IQ have the trained model, our own model, and also use large language model. They can predict the workload optimizer, the job scheduling, which job you should run on which time. So it's decided by AI. And sometimes you have a very big anomaly query. For example, your query scans 7-year data, and the Data IQ will give you the hard blocker and give you alert, and you will handle the additional permission, approval, and run this SQL. And how the catalog plays a role? The catalog, they collect, aggregate the metric, and they're able to trigger the Data IQ agentic workflow. So for example, I can give you one example. We do the data, we call it the data table layout optimization. Basically, when you load the data, you want faster loading, right? But sometimes if you don't do optimization for read, your query will be slow. And sometimes we need to start a table service. And the table service is pretty offline. They will do the table layout optimization. And basically, it is reordering your columns and your table layout. Okay. So the challenge is which table we should do, and we should depend on the query distribution. Those are hard tables, but very slow, and we need to tune. And which partition you want to tune, right? So this all the important metadata information is always changing. The catalog will give you the very accurate information to the agent. Hey, you should start doing this table and this partition. And then when you start working on that, you need a resource, right? Actually, we don't want to add more money on the data IQ. So we ask the catalog to understand all the resource in the real time. So where the young queue is available, where the Kubernetes have the variable too, and they move the job there to run. It all depends on the catalog. So the another value driver, number 4, I think Jerry will talk about that, is very popular right now. And you're working on AI company, you are dealing with the multi-modality data. So I think this is a big challenge. We are running data platform and like container, and our customer drops the data into the box, but actually you have no idea what inside. When they put data over there, right? They put the image, you have no idea what image, the video, the audio. You just see the file. You say, oh, this is the video file. It's how large. The metadata is the location, the size of the video. But you're missing a lot of information. Is the content, right? So this is the rough idea. Actually, we are working with the GCP and GCS together to enable this feature. We call object context. It's about the metadata. So when you drop the data into the GCS bucket, so there's a backend AI job is running. They do content understanding. Okay, it's a multi-modality model. Image, they do image understanding. Video understanding. Audio, right? So for example, this is the Uber Eats menu from the restaurant. Before just the image, we have no idea. Our other engineering team had to do a lot of other work to recognize. So right now, if you drop the picture here, we recognize is the menu, and we generate the tag, the content, a very key value, just like key value pi, right? But those limited information super helpful. So right now, for each object, we can give 8K. It doesn't matter how big your object. For each object, it's 8K. That meaning you can generate 8K key value pi, put it into the metadata. So I think this is not a regular way, but we try to enable this power. That meaning when you put the data into the storage, the value show up. And then also we have the different API. You can directly to listing those attributes or searching, right? For example, there's some example here. You can do the searching pattern. Okay, but that is the bigger change. Before we just understand. I have data, but right now I know what data look like, and I can generate some metadata for our business. So, what is the solution? So, and this is totally changed the metadata catalog landscape. Before is the metadata generated by other third parties, right? I'm like a holding party. I got the metadata. I show something for you, but the new change for the metadata catalog itself should have the capability to understand content and generate the metadata, right? It is a fundamentally change. So like for this example, the data source is multimodality, and then we just have the collector to get all the metadata from different type of data, and then we put it into the catalog. The reason I put it here, Lens, we are working with Lens, is a very popular AI native the data format. So but they are missing the catalog. I think the Data Strato, Uber, and Lens are working together. We are going to publish the catalog, native catalog for Lens. But the good way to think about that is, so the data put into Lens, and Lens can support you to do multiple indexing, embedding, or you have different image multimodality. You can also do indexing or geo-indexing contributed by Uber. But the catalog I have to call the different AI service to generate the catalog, the metadata, and put it back into the Lens. And the way you're using Lens, they call multi-column. You can easily to add a new tag, add a new column. It's not like a query, right? You have to go to the row group. It's just like dynamic adding, extending your table, and with the new catalog, new attribute. So, and also with the catalog solution, before it's just like API call. I want to know where the table, give me location, the URL. But right now support NLP search. You can ask the NLP language for the catalog, and they can discover and give you the matching record. And basically turn on the MCP, and then they can easily work with agent. Okay. So yeah, let me go to the last value drive, number 5. So I think it's a complicated case. I will take a longer time. So yeah, Uber is developing our own agentic data analytics, right? This is an example. Look at the question. I think most of you don't understand the question because it's an internal language to Uber, right? So what meaning F2 report, and what meaning GCS spending, and what meaning as LRP. But that's a reality. If you are working on the similar solution, you probably know what I'm talking. We call taxonomy, right? It's a taxonomy. It's a different company, different team. Or maybe you're in the same industry like finance, you have the same taxonomy. But most of the time, people talk about, the word, the term, they have a special meaning. So, and to answer this question, you want to use a text to SQL solution, right? And most of the time failure because the large language model, they have no idea what you are talking, right? But here we break down to the approach. The first step, the large language model, before we touch the language model, we should search the knowledge. We need a map. So what F2 meaning, what the GCS spending meaning, what LRP meaning, right? We go to the knowledge discovery. And the key question is where I put those knowledge, right? Before it's hard, because I think we talk about metadata, most of people think about metadata is table, column. But actually in the AI world, the first citizen for metadata is taxonomy, the ontology, right? So as a metadata catalog, if they can manage those kind of first citizens for AI, so they don't have to generate a new service. They just go to catalog to search, okay, I want to mapping those terminology. Sometimes it's not exactly matching, right? They give you the most matching record based on the possibility and the user pattern. Okay, like this example, after they finding top to catalog, they're able to understand what F2 is a finance report February 2025, right? That's an important message for AI. Otherwise, they have no idea F2 meaning. If you go to F1, right? What F1 meaning, right? Speeding car, right? So, LRP is a very special terminology in Uber, is a long read plan, is for planning, okay? And also they can search the SOP, how to do the analysis. And then they go to second step, we call semantic understanding. Okay, after I know the terminology and where I should search those resources, I need to understand where the metadata of the resource inside, where the metadata of the LRP planning, where are the aggregated view of cloud spend the last 24 months. So who are managing those kind of semantic attribute catalog? You can talk to the same API, hey, I want to know those kind of semantic information. We call semantic retriever. And then we go to the data insight and analysis. And we're coming to the agentic world. I'm talking about the market agent, right, market stack, and kind of a bubble word. Basically, it's about the two calling, or we call MCP. So then the question is, where are the two, right? Which two is the most suitable for me on this context? Okay, how can I manage those two, right? And people talk about MCP catalog, MCP gateway, and here you go. If you put the MCP or tooling in the metadata catalog, it can also help for you. And with the context searching, and they're able to find the best tool for you, right? And okay, not only the tool, but also right now is very popular thing from the enterprise. And there already reports there were so many security security incidents in production right now. People make MCP2, but without the governance, right? The MCP2 is like hacker, right? So you can touch anything. Basically, and you need to enforce the policy, the governance. Okay, metadata catalog is a wonderful place because it's a governance center. You have all the security policy, permission control, accountability, accounting and auditing, right? So then go to the central place and find each tool. You are the person, you are the agent. Agent, you have ownership or you have the role, right? So are you able to authorize to access it too? Okay, do the checking, do the enforcement. The last one, after you finish, right? I finish my conversation and during the final report, I found my final thing. Okay, here's the challenge. And the people will challenge your funding. And how can you convince me? Give me the trace, give me the thinking step, give me the data footprint. How can you generate your decision? How can I show the data? And then you need to build a lineage This lineage is a conversational based, it's session based. You're able to trace everything from the start beginning, the question, and all the steps you call the tool, and then where you put this lineage, metadata catalog. Okay, I think the metadata catalog plays more and more important role on the agentic application and conversational BI. They work together with the content engineering. But something content engineering, they are focusing on how to build a beautiful and accurate content. But they are looking for so many metadata information, right, during the conversation. And the catalog can play the role. Okay, so this is a very high level picture. So we are thinking the intelligent metadata catalog for agentic AI. Where is the position? You have your product solution, and you build your own agent API, right? So then you start working with the conversational AI interactive session. Basically, you go semantic content engineering. Okay, I want to do that. It's my prompt. I want to do that. And then you start looking the catalog. Why? Because I need to know where's the context, where's the knowledge, where's the semantic, where's the tool. And in this the metadata catalog, you have taxonomy, ontology, SOP, semantic attribute, and absolutely you have your table and column, right? MCP service gateway, governance policy, personalized preference, right? You all manage all the metadata there. And then it's centralized metadata management. You don't have to call so many different tools. Today, before we got the challenge, we have to develop so many MCP tools, but they have just a very special function to just looking and searching some metadata. And then you go to multi-modality data lake, right? Because the metadata able to understand your content, they can generate the attribute for the content, right? You're able to search. On the right side is knowledge platform and how they are interacting with each other. We can see, right, the catalog play a very important role on this picture. Okay, so I got my time. So the key takeaway, when Uber is re-architecting the metadata, we are thinking a different way. So the traditional metadata catalog is not working for Uber anymore. And also basically the data scale isn't our challenge. And understanding, routing, governance, cost efficiency, and autonomous operation is our real challenge. I think with our journey to re-architecting the metadata catalog, we are working closely with the Data Strato and Apache Gravity Node, and we added more additional value into the open source. And in the near future, and Uber will work with the Data Strato to open source most of this feature. I think can share to everyone, and also we are hoping to contribute. Everyone can contribute back to the community. Yeah, that is all my talk. I think the time we have no question, right? After that, okay. So thank you, everyone.
Thank you, Jack, for sharing Uber's experience and worship.